Dear students, in previous class we discussed about monotone sequence of convergence theorem, and also we solved some problems on that theorem. Today also we solved some problems. ఇంతకు ముందు క్లాస్లో మనము అభిసరణ సిద్ధాంతం యొక్క నిరూపణ మరియు ఆ సిద్ధాంతంపై కొన్ని ప్రాబ్లమ్స్ కూడా మనం సాధించడం జరిగింది. ఈరోజు క్లాస్లో కూడా మనం కొన్ని ప్రాబ్లమ్స్ గురించి డిస్కషన్ చేద్దాం. టుడే ఈజ్ ఫస్ట్ ప్రాబ్లం. ప్రూఫ్ దట్ Sn equal to 2 minus 1 by 2 to the power of n minus 1 is convergent. Sn equal to 2 minus 1 by 2 to the power of n minus 1 అభిసరణ చెందుతుందని చూపండి. Now we have to prove given sequence is convergent. Before that given sequence will be is a monotone sequence or it is a bounded above or bounded below sequence. So monotone sequence means if any sequence is increasing or decreasing, that sequence is called monotonic sequence. ఏదైనా ఒక అనుక్రమం ఆరోహణ లేదా అవరోహణ అనుక్రమం అయితే ఆ అనుక్రమాన్ని మోనోటోన్ సీక్వెన్స్ అని అంటాము. సో కాబట్టి ఇచ్చినటువంటి అనుక్రమాన్ని ఇప్పుడు మనం ఆరోహణ లేదా అవరోహణ అనుక్రమం అని చూపిస్తే ఇట్ ఈస్ ఎ మోనోటోన్ సీక్వెన్స్ అవుతుంది. So from the theorem of monotone sequence convergent theorem, it is a convergent sequence. So now what is the given sequence here? ఇచ్చినటువంటి అనుక్రమం Sn equal to 2 minus 1 by 2 to the power of n minus 1. Now let's consider Sn plus 1. So Sn plus 1 means you can put in place of n equal to n plus 1. ఇచ్చినటువంటి అనుక్రమంలో n యొక్క స్థానంలో n plus 1 రాస్తే 2 minus 1 by 2 to the power of n plus 1 minus 1. So here minus 1 plus 1 is cancelled. We get here Sn plus 1 equal to 2 minus 1 by 2 to the power of n. But we know for all n belongs to z plus, we know 2 to the power of n always greater than 2 to the power of n minus 1. 2 to the power of n greater than always 2 to the power of n minus 1. Because of here 2 to the power of n minus 1 is the one of the term of in Sn. And also 2 to the power of n is the one of the term of in Sn plus 1. So that's why I am taking here the relation between 2 to the power of n, 2 to the power of n minus 1. What here 2 to the power of n is greater than 2 to the power of n minus 1 for all n belongs to z plus. Now changing the numerator and denominator here. So that implies we get here 1 by 2 to the power of n less than 1 by 2 to the power of n minus 1 for all n belongs to z plus. 1 by 2 to the power of n less than 1 by 2 to the power of n minus 1 for all n belongs to z plus. So that implies now we can write as 2 minus 1 by 2 to the power of n greater than 2 minus 1 by 2 to the power of n minus 1 for all n belongs to z plus. So n యొక్క ఏ ధనాత్మక పూర్ణాంక విలువకైనా 2 minus 1 by 2 to the power of n greater than 2 minus 1 by 2 to the power of n minus 1 అవుతుంది. So now here 2 minus 1 by 2 to the power of n is a Sn plus 1, sequence of Sn plus 1, and 2 minus 1 by 2 to the power of n minus 1 is the sequence of Sn. So here whatever here, so Sn plus 1 greater than Sn. So that means sequence of Sn is a increasing sequence. So therefore Sn is an increasing sequence. So ఇక్కడ ఇచ్చినటువంటి అనుక్రమం Sn అనేది ఒక ఆరోహణ అనుక్రమం. సో ఆరోహణ అనుక్రమం కాబట్టి ఆరోహణ అనుక్రమం, సో ఇట్ ఈస్ an increasing sequence. సో ఇట్ ఈస్ బౌండెడ్ బిలో సీక్వెన్స్. ఇది ఆరోహణ అనుక్రమం కాబట్టి దిగువబద్ధ అనుక్రమం అవుతుంది. సో దిగువబద్ధ అనుక్రమం అవుతుంది అంటే it has infimum. So now we have to prove it has supremum value. సో ఇప్పుడు మనం Sn అనేది ఎగువబద్ధ అనుక్రమం అవుతుందని చూపిస్తే, సో given sequence is the bounded sequence. So every bounded sequence is convergent sequence. That's why the problem is proved. So now I am taking here and also Sn equal to 2 minus 1 by 2 to the power of n minus 1 less than 2, because of here 1 by 2 to the power of n minus 1 is subtraction from 2, so it is a always less than 2 for all n belongs to z plus, and so therefore Sn less than 2. So here 2 is the supremum of Sn. Here 2 is the supremum of Sn. So Sn is bounded above. So Sn is increasing and bounded above sequence. So that's why it is a monotone sequence. So every monotone sequence is convergent, because of every monotone sequence is bounded sequence. So every bounded sequence is convergent sequence. సో ఇచ్చినటువంటి అనుక్రమం ఆరోహణ అనుక్రమం మరియు ఎగువ వద్ద అనుక్రమం కావున ఇది మోనోటోన్ సీక్వెన్స్ అవుతుంది. సో ప్రతి మోనోటోన్ సీక్వెన్స్ పరిబద్ధ అనుక్రమం, ప్రతి పరిబద్ధ అనుక్రమం అభిసరణ అనుక్రమం అవుతుంది. సో గివెన్ సీక్వెన్స్ Sn is పరిబద్ధ అనుక్రమం. సో గివెన్ సీక్వెన్స్ is convergent sequence. So this is the solution of the problem. So now another problem. So here I am giving some note. ఇక్కడ నేను ఒక గమనిక ఇస్తున్నాను. So what is the note here? So see the notes. A plus AR plus AR square plus and so on AR to the power of n. Now I am taking here common A of 1 plus R square plus and so on R to the power of n. It is in GB. ఇది ఒక గుణాత్మక శ్రేణిలో ఉన్నది. ఇది ఒక గుణాత్మక శ్రేణిలో ఉంది. So A of 1 plus R square plus and so on R to the power of n is in the form of GB. ఇది ఒక గుణాత్మక శ్రేణిలో in GB series. So what is the formula here? If R less than 1 and if R greater than 1, we have two formulas. అంటే it is the sum of that GB. ఆ గుణాత్మక శ్రేణి యొక్క మొత్తం is equal to the two formulas we have. So first case is R less than 1 and second case is R greater than 1. So if R less than 1, we have the formula A of 1 minus R to the power of n plus 1 by 1 minus R. What is the formula here? If R less than 1, we have the formula A of 1 minus R to the power of n plus 1 by 1 minus R. And if R greater than 1, we have the formula A of R to the power of n plus 1 minus 1 by R minus 1. So if R greater than 1, we have the formula A of R to the power of n plus 1 minus 1 by R minus 1. It is a second case if R greater than 1. Now I am giving here two examples. So first example is, it goes to first case. First case means if R greater than 1. So what is the example here? 1 plus 2 plus 2 square plus and so on 2 to the power of n. 1 plus 2 plus 2 square plus and so on 2 to the power of n. Here R equal to 2. So 2 is always greater than 1. So we can use the second condition. If R greater than 1, we have the formula what here? Here A equal to 1. So R equal to 2. So 2 to the power of n plus 1 minus 1 by 2 minus 1 equal to 2 to the power of n plus 1 minus 1. It is the sum of that శ్రేణి, ఆ సిరీస్ యొక్క టోటల్ పదం. అలాగే 1 plus 1 by 2 plus 1 by 2 square plus and so on 1 by 2 to the power of n. Here R equal to 1 by 2. So 1 by 2 is the less than 1. So 1 by 2 is the less than 1. So now it is equal to 1 minus 1 by 2 to the power of n plus 1. 1 minus 1 by 2 to the power of n plus 1 by 1 minus 1 by 2. So in the denominator 1 minus 1 by 2 is 1 by 2. So 1 by 2 means we have to goes to here 2 is in numerator. To go to numerator. So 2 of 1 minus 1 by 2 to the power of n plus 1. So that's why now multiplying with 2. So 2 minus 1 by 2 to the power of n is the sum of the series. So now we are solving the one problem on that formula. ఈ సూత్రం పైన మనం ఒక ప్రాబ్లం ని ఇక్కడ సాల్వ్ చేసుకుందాం. సో That problem is, if Sn equal to 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by n factorial, then prove that Sn is convergent. If Sn equal to 1 plus 1 by factorial, 1 plus 2 factorial plus and so on 1 by n factorial అయితే Sn అనుక్రమం అభిసరణ చెందుతుందని చూపండి. సో అభిసరణ చెందుతుందని చూపండి అంటే ఇచ్చినటువంటి అనుక్రమం ఆరోహణ అనుక్రమమా అవరోహణ అనుక్రమమా కనుగొనాలి. ఆరోహణ అవరోహణ అనుక్రమమైన తర్వాత అది ఒక పరిబద్ధ అనుక్రమముని చూపాలి. If it is bounded sequence, then it is a convergent sequence because of by the theorem of convergent monotone sequence convergent theorem. సో monotone sequence అభిసరణ సిద్ధాంతం ప్రకారంగా అది అభిసరణ చెందుతుందని చెప్పవచ్చు. సో now first of all we have to prove it is a increasing sequence or decreasing sequence. After that we can find after that we can show that it is a bounded sequence. So now what is the given sequence here? First of all, so here given sequence is defined by Sn equal to 1 plus 1 by 1 factorial plus 1 by 2 factorial plus and so on 1 by n factorial. Now I am taking here Sn plus 1. I am taking here Sn plus 1 because of we have to find it is increasing or decreasing. So that's why I am taking here Sn plus 1. So Sn plus 1 equal to 1 plus 1 by 1 factorial plus 1 by n factorial plus and so on 1 by n factorial plus and 1 by n plus 1 factorial. So it is a here nth term is the 1 by n plus 1 factorial. So before all terms are belongs to Sn. దాని ముందున్నటువంటి అన్ని పదాలు కూడా Sn లోని పదాలే. So that's why I am writing here Sn plus 1 equal to Sn plus 1 by n plus 1 factorial. Sn plus 1 equal to Sn plus 1 by n plus 1 factorial. So now I am taking Sn from left side. We get here Sn plus 1 minus Sn equal to 1 by n plus 1 factorial. So it is a positive number. It is a positive number because of for all n belongs to z plus here. So here n is a positive integer. You can give the any positive integer. We get here all 1 by n plus 1 factorial is always greater than 0. So that's why left side value is also. So left side value is what here? Sn plus 1 minus Sn is also greater than 0 for all n belongs to z plus. So therefore Sn plus 1 greater than Sn for all n belongs to z. So what is the meaning of here? Sn plus 1 greater than Sn means it is a increasing sequence. So given sequence is increasing sequence. So increasing sequences means it is a bounded below and it has lower bound of Sn. It has lower bound. So here lower bound is the S1. So S1 is the lower bound of Sn. So it is a increasing sequence. So increasing sequence means it is a bounded below sequence. Bounded below sequence means it has lower bound. So lower bound means here S1 is the lower bound of Sn. S1 అనేది అనుక్రమం Sn యొక్క దిగువ హద్దు అవుతుంది. So now S1 less than or equal to Sn. But we know S1 from the sequence. S1 equal to what here? 1 plus 1 factorial. 1 plus 1 by 1 factorial. So 1 plus 1 by 1 factorial means 1 plus 1 equal to 2. So now here first term of the sequence is 2. So first term we have to denote it by S1. So here S1 equal to 2. So 2 less than or equal to Sn for all n belongs to z plus. So now we have to find supremum of Sn. So it is a bounded above sequence అని చూపించాలి మనం. ఇది ఎగువ పరిబద్ధ అనుక్రమం అని చూపించాలి. ఎగువ పరిబద్ధ అనుక్రమం అవుతుందంటే దానికి ఎగువ హద్దు ఎగ్జిస్ట్ అవుతుందని అట్లా అర్థం. సో దానికోసం ఇక్కడ నేను ఏం తీసుకుంటున్నా అంటే నౌ we have taking here 1 equal to 1. It is always true. 1 equal to 1. So similarly 1 by 1 factorial equal to 1. It is also true. 1 by 1 factorial equal to 1. It is also true. So 1 by 2 factorial equal to what here? 2 factorial means 2. So 1 by 2 factorial equal to 1 by 2. It is also true. So now 1 by 3 factorial. 1 by 3 factorial is equal to 1 by 6. But here I am taking 1 by 6 is always less than 1 by 4. 1 by 6 always less than 1 by 4. But I am writing 1 by 4 as 1 by 2 square. 1 by 6 అనేది 1 by 6 అనేది 1 by 4 కన్నా చాలా చిన్న విలువ కాబట్టి 1 by 6 less than 1 by 4. కానీ ఇక్కడ 1 by 4 ను 1 by 2 square గా రాస్తున్నాను because of the పైన విలువ the above value is in the form of 1 by 2. So similarly we have to write 1 by 4 factorial. 1 by 4 factorial means it is equal to 1 by 24. 1 by 24. But 1 by 24 is less than 1 by 8. But 1 by 24 is less than 1 by 8. So I am writing here 1 by 8 as 1 by 2 cube. 1 by 8 no 1 by 2 cube ga rasunanu. So that's why and so on I am writing 1 by n factorial always less than 1 by 2 to the power of n minus 1. పై పదాలను బట్టి దాని యొక్క ఎన్నో పదాన్ని నేను ఈ విధంగా రాయగలుగుతున్నాను 1 by n factorial less than 1 by 2 to the power of n minus 1 because of 1 by 4 factorial is less than 1 by 2 to the power of cube. Here 4 equal to n and 3 is the n minus 1, so 4 minus 1. So now 1 by n factorial less than 1 by 2 to the power of n minus 1. Now here I am doing now adding the above inequalities పై అసమానతలన్నిటిని కూడగా. So now add the left side terms and right side terms we get here. So now first of all I am adding the left side terms 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial plus and so on 1 by n factorial less than or equal to. So some terms are equal here, some terms are less than. So that's why I am taking here less than or equal to. Some terms are all are equal, some terms are less than here. So that's why I am taking here less than or equal to. So right side terms are 1 plus 1 by 2 to the power of 0. 1 by 2 to the power of 0 means 2 to the power of 0 equal to 1. So first two terms are 1. So 1 plus 1 by 2 to the power of 0 plus second term is 1 by 2. So 1 by 2 means 1 by 2 to the power of 1. Third term is 1 by 2 square plus and so on. Nth term is the 1 by 2 to the power of n minus 1. So equal to 1 plus of. It is in the form of GP. It is in the GP series. ఈ రైట్ సైడ్ ఉన్నటువంటి టోటల్ పదం మనకు గుణాత్మక శ్రేణిలో ఉన్నది కాబట్టి here r equal to 1 by 2. Here r equal to 1 by 2. So 1 by 2 is the less than 1. So we have the formula. If r less than 1, we have the formula a into 1 minus 1 by a minus a of 1 minus r to the power of n by 1 minus r. So here r equal to 2 to the power of 1, r equal to 1 by 2. So 1 plus of 1 minus 2 to the 1 by 2 to the power of n by 1 by 1 minus 1 by 2. So now in the denominator 1 minus 1 by 2 means 1 by 2. So 1 by 2 means we get here in the numerator 2. So 1 plus 2 of 1 minus 1 by 2 to the power of n. So now multiplying with 2 of 2 minus 1 by 2 to the power of n minus 1. So 1 plus 2 how much? 3. 1 plus 2 3. So 3 minus 1 by 2 to the power of n minus 1. 3 minus 1 by 2 to the power of n minus 1 is less than 3. Is less than 3. For all n belongs to z plus because of 1 by 2 to the power of n minus 1 is subtraction from 3. 1 by 2 to the power of n minus 1 is subtraction from 3. So it is always less than 3. It is always less than 3. So therefore here Sn less than 3. So less than 3 means it is a 3 is the supremum of Sn. 3 is the supremum of Sn. So it is bounded above sequence. It is bounded above sequence. Already we have infimum. We have infimum of Sn is what? S1. S1 equal to 2. So 2 less than or equal to Sn less than 3. So it is bounded sequence. So by monotone convergence theorem, it is a convergent sequence. అభిసరణ సిద్ధాంతం ప్రకారం ఇది అభిసరణ అనుక్రమం అవుతుంది. ఇది పరిబద్ధ అనుక్రమం కాబట్టి by monotone convergence theorem ప్రకారంగా ఇది అభిసరణ చెందుతుంది. So therefore problem is solved. So now we have to solve another problem. It is also some different problem. Proof that the sequence Sn is defined by S1 equal to root C greater than 0. S1 equal to root C greater than 0, comma Sn plus 1 equal to root of C plus Sn for all n belongs to n. So here n is a countable set, natural number set. Convergence to the positive root of x square minus x minus c equal to 0. ఇచ్చినటువంటి Sn అనుక్రమాన్ని మనకు S1 equal to root c greater than 0, Sn plus 1 equal to root c plus Sn for all n belongs to n గా నిర్వచిస్తే ఇది ధనాత్మక విలువలకు x square minus x minus c equal to 0 ధనాత్మక మూలాలను కలిగి ఉంటుందని చూపండి అని అంటున్నాడు. సో the sequence Sn is defined by S1 equal to root c is greater than 0 and Sn plus 1 equal to root of c plus Sn for all n belongs to capital N. So now Sn equal to root c. Now I am finding S2 value. So second term of the sequence. Now I am finding second term of the sequence. So second term of the sequence means you can put in Sn plus 1 n equal to 1. So S2 equal to root of c plus S1. But S1 equal to already given root c. So now substitute here root of c plus root c. So it is a S2. So now consider c equal to c. It is true. C equal to c. So any constant value, you can give the any constant value, it is true. C equal to c. But c less than c plus root c. You can give the c equal to 2. So 2 equal to 2. But 2 less than 2 plus root 2. 2 less than 2 plus root 2. So here root 2 equal to some value. So some value is adding to 2. So that's why 2 less than 2 plus root 2. So c less than c plus root c. So now I am taking on both sides square root c less than root of c plus root c. But root c equal to S1. And root of c plus root c is S2. So S1 less than S2. So what here observe this first term is less than second term. So S1 less than S2. So that means given sequence is increasing sequence. ఇచ్చినటువంటి అనుక్రమం ఆరోహణ అనుక్రమం అని తెలుస్తుంది. కాబట్టి ఇది మనం ప్రూఫ్ చేయాలి. ప్రూఫ్ మీన్స్ Sn plus 1 Sn less than Sn plus 1 అని ప్రూఫ్ చేయాలి మనం. So it is true for n equal to 1. So now we have to prove Sn less than Sn plus 1. మనము Sn less than Sn plus 1 అని ప్రూఫ్ చేస్తే ఇచ్చినటువంటి అనుక్రమం ఆరోహణ అనుక్రమం అని చెప్పవచ్చు. So it is true for n equal to 1. ఇది n equal to 1 కి నిజము. So let it is true for n equal to m. Now we have to prove by mathematical induction method. దీన్ని గణితానుగమన సిద్ధాంతం ప్రకారంగా నిరూపించాలి. So let it is true for n equal to m. So n equal to m means Sm less than Sm plus 1. So that implies now adding on both sides c plus Sm less than c plus Sm plus 1. So now taking on both sides root of c plus Sm less than c plus Sm plus 1. By given problem, in the problem, root of c plus Sm is Sm plus 1. So less than, so it is a Sm plus 2. So it is true for n equal to m plus 1. ఇచ్చినటువంటి ప్రాబ్లం నుంచి రూట్ ఆఫ్ సి ప్లస్ ఎస్ఎం ను ఎస్ఎం ప్లస్ 1 గా రాస్తున్నాం. అదేవిధంగా రూట్ ఆఫ్ సి ప్లస్ ఎస్ఎం ప్లస్ 1 ను ఎస్ఎం ప్లస్ 2 గా రాస్తున్నాం. సో ఇట్ ఈస్ ట్రూ ఫర్ n ఈక్వల్ టు m ప్లస్ 1. బై మ్యాథమెటికల్ ఇండక్షన్, బై గణితాంగ సిద్ధాంతం ప్రకారం Sn less than Sn plus 1. Sn less than Sn plus 1. So Sn is increasing sequence. So Sn is increasing sequence. So increasing sequence means it is a bounded below and it has lower bound. Increasing sequence అంటే ఇది దిగువ పరిబద్ధ అనుక్రమము మరియు ఇది దిగువ అద్దును కలిగి ఉంటుంది. సో దిగువ అద్దును కలిగి ఉంటుందంటే S1 is the bounded below of a lower bound of Sn. దిగువ అద్దును కలిగి ఉంటుంది కాబట్టి ఇక్కడ S1 అనేది Sn కు దిగువ హద్దు అవుతుంది. సో Sn is bounded below sequence and lower bound of Sn is S1. So S1 less than Sn for all n belongs to capital N. So but we know value of S1. So root C less than Sn for all n belongs to capital N. Now we have to prove it is a bounded above. It is a bounded above. So from this equation and we have to prove bounded above. From that it is a bounded sequence. So now let S1 equal to root C is always less than C plus 1. You can give the C equal to any positive value. You can give the C equal to any positive value. For example, C equal to 2. For example, C equal to 2. So root C equal to what? 1.414. Root 2 value is the 1.414. But 2 plus 1, 3. So 1.41 is less than 3. So it is true for n equal to 1. So now let it is true for n equal to m. N equal to m ku ఇది నిజమని అనుకుందాము. So that means Sm less than C plus 1. Sm less than C plus 1. Now adding on both sides C. ఇరువైపుల C ని కలుపుతున్నాను. C plus Sm less than C plus C plus 1. So C plus Sm less than, in the right term, C plus C plus is 2C. So 2C plus 1. So I am taking on both sides root. ఇరువైపుల root ని తీసుకుంటే root of C plus Sm less than root of 2C plus 1. But here root of 2C plus 1 is always less than root of C square plus 2C plus 1. C square plus 2C plus 1. Because of C square plus 2C plus 1 is C plus 1 whole square. But right side term square root both are cancelled. Root of C plus Sm less than C plus 1. It is true for m equal to m plus 1. It is true for m equal to m plus 1. Because of first term is also less than C plus 1 and nth term is also less than C plus 1. So it is true for n equal to m plus 1. So by mathematical induction, we can write as Sn less than C plus 1. Sn less than C plus 1. But already under C plus 1 means C plus 1 is the upper bound value of Sn. C plus 1 అనేది Sn యొక్క ఎగువ హద్దు అవుతుంది. C plus 1 అనేది upper bound of Sn. So it is a bounded above sequence. So now let us denote it as equation 2. Now already from we have equation 1. We have equation 1. From 1 and 2 we have to write root C less than Sn less than C plus 1. Root C less than Sn less than C plus 1. So that means root C is the infimum of Sn. C plus 1 is the supremum of Sn. Root C is the infimum of Sn. C plus 1 is the supremum of Sn. So it is a bounded sequence. It is a bounded sequence. So it is bounded and monotone sequence. It is bounded and monotone sequence. So by monotone convergent theorem, every convergent sequence is bounded and every bounded sequence is convergent. So now here given sequence is convergent. Sn is convergent sequence. Sn is convergent sequence. So now we have to prove it is a positive roots. It is a positive roots. So now it is a convergent sequence. So you can take Sn is convergence to L. అనుక్రమం Sn అనేది L కు అభిసరిస్తుందని అనుకున్నాం. So that means limit Sn equal to L. Limit Sn equal to L. That implies we have to write limit Sn plus 1 equal to also L. Limit Sn plus 1 equal to L. So, but Sn plus 1 equal to, from problem we have root of C plus Sn. Sn plus 1 equal to, from problem we have ఇచ్చినటువంటి ప్రాబ్లం నుంచి Sn plus 1 equal to root C plus Sn అని తెలుసు. Now square on both side, ఇరువైపుల వర్గం చేస్తే s square n plus 1 equal to square root cancel C plus Sn. Now take the right side term from left side. కుడివైపు ఉన్నటువంటి ప్రాబ్లంలో ఎడమవైపు తీసుకొస్తే s square n plus 1 minus Sn minus C equal to 0. Now apply the limit. Limit of s square n plus 1 minus Sn minus C equal to 0. But limit Sn plus 1 equal to L. So that means L square here. Limit Sn equal to L. So L square minus L minus C equal to 0. So the given sequence Sn converges to positive root of x square minus x minus C equal to 0. So therefore ఇచ్చినటువంటి అనుక్రమము x square minus x minus C equal to 0 కు ధనాత్మక మూలాలకు అభిసరణ చెందుతుందని చెప్పవచ్చు. So this is the today class.